cool with whatever we do. You love no love with whatever we do. Hale yi demuñu school ñepp xam ne nekkul lu cool ñepp a ngi ragal a génn ñepp xam ne nekkul lu cool ibuloke nongoto ni beti sola ibuloke dato ni betoto
Bege Congo
Lamin te jibe norin te ñamen Lamin
kabana wulo
kono ñin tay mo Lamin
pa bi lenki
muna ngata afamole
hayna
ngata ngoto le Fabrama
Mingi baba ñolle
no ngoto le Fabrama
namu jumala kan kuma diten
Fabrama
jumala mu
tele ware muso
nunda mana jamani bere
lindo ko
jamani
bari ngoto man kontande
bari jamani fana na mudu wa kontan
ngoto mina filitala Lamin jibe nori nyala
Lamin ila siran sama ne benki yala so tol sayni no ko mo lokko momo
ngodo
nam
itedinte yalo ne Lamin hakkilo diata bake karambu ngoto anu santeng ministry ko di ngole si suko ko amanke ko do holi de
si bitun
bagona de
ala ni nya ko kede namo ba
ala na ko karta bulo be da nije
ngodo
nam
ngoto mon kontan feren
jamani mu ne keda
ka Lamin ki wulo ko no nyin tay mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamu be sorande ne ko fasi ka wulo ko nako
baba
karambu wol ni ko karamu wol sorande amanke kom holiday lem ngodo dindi wo nyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda la kombo len do la jan karamu wol sorande do kamen courant ma ra do la kombo e ko ndol fana na karamu wol sorande Lamin ada lo nyino la amanta ra fe na so kon ala mu nekela
Lamin ite fete malon ko lesinol be ke kar radio to
nga fine
e ko yana di mo Lamin ya mu na fonye
bi kabin mina kan tambita nteri maning Fatu
ha
tambite la sugal ala dinngol bebe siri be la moy ka
Fatu dan so am fana tambita jere ni subala la ngaje dinngol be jet talanta nen kili waro e be seri jelet
sa Lamin fanante ku kili wo ke no la ba Lamin bita ka wulo ko no nyin tay mo Lamin
amanda ra fenela
ite dine ko ni man si yakaru lesinol la moy radio to e balon na
mu ne ka ke afonde ma nyara ni alon
telentel jikot
afonde ma mu ne be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa mala ya itarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin ma nyata la wulo ko adu karam mo be so da fa ñembe
ko to wole nati bawo ngal le ni Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no ni ko e sisu ko no be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo ba radio be bulan ko to batiri sanga ay si ay alamo
do kala nyaadi
ko ta ho bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ile subject ro baby jele baby jele
wala nanga coco moy fa dan so wolya ngombe tambi kana ngadi ni wolje be ikadum bungo de ko kala
ma asototal de
Lamin mala be karawala de
bari laftalal idealon ko every second wala fourth
muna ni ko di ko nde ko folle sini lamba ndele sini lo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yin fana bulata ko ko me yen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro Lamin nyanta kara si so na
radio la sila le ayala le sino
dal ko korno ko smalo
kilar ya
be ngala ko momo sa mi do ni ko no kera
mengi bruzo
ndelo ko do la da baro sa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan dala nyara nyar woro ko fendi mo la Lamin tayra ba do sa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
imagine nani nyambol sizol ne keje kisigi man sizol no le kafun ka nyoma bari nyambu kilo ni manya na kafindi ni nambe ko rozor laga
ngale limbeta de be nyambo do dilanna
nyar ko irin fennat nyara nata
bari famo ke da
ngata bungono tammi bungono nyara ngando ko fele ko ke baru nganda ni pelo landi jak
iyo awe betar la
bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro
Hello, wonderful viewers and listeners out there. Welcome to another lesson for the senior secondary school category. Remember, it's your teacher, Mr. Mas Jame. Today's lesson is bearings. This is a lesson or a topic learned from the upper basic and senior schools and even tertiary institutions as well. Now, if I may ask this question, what is bearing? From the board, you can see clearly that bearing is the clockwise angular relationship between two distant places measured in degrees from the north. I repeat, what is bearing? Bearing is the clockwise angular relationship between two distant places measured in degrees from the north. I think that message is very clear. Now, from the introduction, I would like to mention that we have two kinds of bearings. And what are these two kinds of bearings? The two kinds of bearings are, one, we have compass bearings. I repeat, among the two types or kinds of bearing, we have compass bearings. The second type of bearings is three-figure bearings. The second type of bearing is the three-figure bearings. So in short, learners by now must have known that bearings in our lesson here will be dealt with in two different categories. That is the compass bearing and the three-figure bearings. Now, in bearing, what I normally tell students is that to get a better understanding about bearings, the key behind the lesson is the 4 cardinal points of your compass. Now, if you look at these 4 cardinal points that we have on the board, the knowledge about bearing is encompassed by this information. And this is something that we have been learning, or we learn since the primary school level in our SES and in mathematics at some extent. Now, if you look at the 4 compass bearing, as you can see on the screen, on the top there is labeled N. And what is N? N is representing the word north. So the N represents north. E represents east. S represents south. And W represents west. Now, these are the 4 points that give us the 4 cardinal points. Now, looking at the top of each letter or alongside each letter is a number. The first number there attached to N is measured 0 degrees. To E, we have 90 degrees. To S, we have 180 degrees. And then to W, which is the west, we have 270 degrees. Now, if you look at these 4 compass points, I normally mention this in my lessons as reference points on the cardinal points. Why are they reference points? Because they are fixed and can be measured easily using your protractor. Now, before we move further to the discussion of the various kinds of bearing, I would like to say a few things before we reach to that level. Now, generally, if you look at bearings, there are 3 main features that you need to look into. Among the 3 major features are 1, bearings should be measured from the north. That's one feature. 2, bearings should be measured in a clockwise direction. And 3, bearings should be written in 3 digits, except in the case of what? Compass bearing. So we need to take note of these 3 features. And as we look into the 2 different kinds, you will get a clear idea about what I'm trying to mention here. Now, the first kind of bearing or type of bearings that we would look into is the compass bearing. What is this compass bearing? Now, we say compass bearings are based on the 4 cardinal points, which is the north, the south, the east, and the west, as we just discussed in the previous slide. This is it. So if you look at the 4 cardinal points, we have the north and south, we have the east and the west. Now, usually on the compass bearing, if I should give you an example of how values can be given regarding compass bearing, we have an example here. I said, example, north 50 degrees east means, if I should read it, is measure from the north 50 degrees towards the east in a clockwise direction. That is what it means here. If you look at this sample, south 50 degrees west, it means from the south, you have to measure or turn from the south pole 40 degrees towards the what? The west. And that will give you that angular bearing of south 40 degrees west. The next slide is showing the 8 compass points. Now, if you look at the 4 cardinal points, initially, we have the north, south, east, and the west. So this time around, we have how many? 8 compass points. Now, each of these compass points has a bearing, which can be measured if you use the right tool to do the measurement. But also, looking at the features of the diagram, you can still give somewhat angular measurements. How? Now, to start from the north, remember, that's where we start the measurement. So the measurement here is what? Is 0 degrees. And you were told that we measure all bearings from the north in a clockwise direction. Now, if you look at the division of the 4 cardinal points, they are able to make a division of what? 4 quarters. And each of the quarter is a quadrant. And in each quadrant, we measure what? 90 degrees. Now, if you look at the 4 cardinal points, each of them is a quadrant, and each quadrant measures what? 90 degrees. So if you take lines like we have northeast to southwest and southeast to northwest, they are able to divide the 90 degrees into what? 2 equal parts. And this gives an angular measurement of what? 45 degrees each. So it means if this is 0 degrees here, we have the right to put 45 degrees here as the measurement for northeast. If that angle is 45, adding 45 plus 45, remember you are moving to this line here, will give us what? 90 degrees. If you move from this point again, as you continue moving down to this line here, this will give you, remember, each of these is 45 degrees. This will give us 135 degrees. And if you extend the movement again, will take us to 180 degrees. As you keep moving again, we are adding 45 consecutively, will give us 225 degrees. And if you continue the movement to this other line, that will give us 270 degrees. And again, if you move to the line northwest, will give you 315 degrees. And then if you move back to the origin, that will be what? A complete circle, and that's going to be 360 degrees. So these are very, very important messages that we need to take note of, especially when handling what? Compass bearing problems. We have examples of compass bearing. I want us to look at it together. I will label this as question A, and then this as question B. Now, in question A, Remember, we are dealing with compass bearing. All the knowledge is based on compass bearing only. That's why you can see the 2 digits written there with the northeast. N means north and then E is east. So the compass bearing given on the board here is measured from the north. And the measurement given to this line here. So this is the bearing given. The measurement given is 50 degrees. So if you look at this, if I want to write it in a word problem form, it means the question is north 50 degrees east. That is the information represented in the diagram. So if a question is given to you like this is how you represent it in a diagram form. Okay. Now, in the B part, this is the bearing. Remember, in the examples we discussed about on compass bearing, we have 40 degrees, and the angle is formed between south and then southwest. So meaning the bearing, as we move from the north, should be like that. We are turning in a clockwise direction. So here, the turning point, we are told that to start from the south to where? Towards the west, and the angular measurement there should be what? 40 degrees. So if I'm going to write this as a compass bearing, it's going to be south 40 degrees west. We have another question. Now, this is a very interesting question, and I would urge audience and listeners to pay attention to what we are going to do. Now, is a question that we are going to study. Look at the features of the diagram properly, and that will enable us to answer the various questions. The question reads, find the compass bearing of the following. I repeat, find the compass bearing of the following. The following are, A is in the diagram, we can all see A. B is in the diagram, we can all see B. C is also in the diagram, as you can see. Now, all these lines are from the origin. And where is the origin? Is the center of the 4 cardinal points. Now, in between, or between the lines, you can see angular measurements. 30 degrees is there between A and the east. 19 degrees is there between south and letter B. And 32 degrees is there between letter C and the north. So we are going to find the compass bearing of the following. The first one is A. How do we do that? Can we look at it together? Now, to solve the first one, from the compass bearing, we are going to find the bearing of A from O. And what is that O, like I said, is the origin that is from the center of the 4 cardinal points. Now, to help you get the value of A, I said you have to take the bearing from the origin, O. And how can you do that? The angle given in the first quadrant is between the north and the east, and the compass bearing there is 30 degrees. But we are asked to find the bearing of what? A, from the diagram. And remember, all bearings are measured from the north in a clockwise direction. So we can draw a line from here to the line connecting O and A. So to get this bearing, what are you going to do? I mentioned earlier on that in each quadrant, the measurement there is what? 90 degrees. So if I know that the whole of this angle here is 90, and part of the angle is known as 30, you can easily tell the remaining part of the angle. And how can you do that? So to solve the first part, we are going to say the bearing of A will be equals to 90 minus 30, and that will give us 60 degrees. So the bearing of A in the diagram is going to be 60 degrees. Mind you, we are asked to find the compass bearing of A from the figure. So the compass bearing of A from the figure is going to be equals to north 60 degrees of what? East. So this is going to be the answer to A. Now, let's find the compass bearing of B. The compass bearing of B from the diagram is here. If you can see the point I'm trying to emphasize. And the angle there is 19 degrees. So the compass bearing of B is going to be south 19 degrees west. Why? Because the bearing is turning from the south towards the west. The third part of the question, we are asked to find the compass bearing of C. And look at where C is. The angle given there is 32 degrees. So the compass bearing of C is going to be, we have 32 between the north and line C. So remember, we measure from the north, 32 degrees towards the west. So this is going to be the compass bearing of C. So in summary, the compass bearing of A is north 60 degrees east. The compass bearing of B is south 19 degrees west. And the compass bearing of C is north 32 degrees west. The next type of bearing is the three-figure bearings. Now, in three-figure bearings, when we talk about bearing nowadays, we mean three-figure bearings. Examples of three-figure bearings are, the first number I gave there is 00 degrees, and that's the point where we start measuring all angles. You can also have 001 degrees, is a three-figure bearing. You can also have 025 degrees, is a three-figure bearing. You can also have 135 degrees, which is a three-figure bearing. Then the last one of the list there is 360 degrees. Okay, so all these are in the form of what? A three-figure bearing. So I want students to know that the three-figure bearing is very, very important, and penalties are attached to students that will never observe the rules of what? Indicating zeros or a zero to make a number to what? A complete three-figure bearing. We are still in the topic bearing. We are going to look at reverse or back bearings. And like I used to emphasize to students that in reverse or back bearings is a very, very important aspect, because it's the beginning of how to tackle bearings, especially when dealing with questions in your WAS examination. Now, the idea of reverse bearing should not be an exception, and I'm urging students to pay much attention and then work along with me as I solve most of the questions on the board. Now, from the notes we said, in general, if the bearing of B from A is theta, and the symbol for theta is this, then the bearing of A from B is called the reverse or back bearing. Note that there are rules to obey in dealing with reverse or back bearing. You need to know that if theta is less than 180, we add theta to what? 180 to get the results of the back bearing. And if theta is greater than 180, we subtract 180 from theta to get the result for the back bearing. Okay? So we are going to do this in the subsequent slides that we will come across. And like I said, get yourself equipped and then we solve these things together. Example 1. The question reads, if the bearing of y from x is 60 degrees, written 060 degrees, find the bearing of x from y. We are given, and they're asking us to find in the reverse. And I would like to make this emphasis. There is a big problem to most of the students, especially when analyzing bearings of this type. And my emphasis here is going to be laid on what? The connection of the two locations. The two locations in this question are y and x. The word connecting y and x is what? From. So in this case, the word from there should be what? Giving an attention, special attention for that matter. Why giving it a special attention? Now to locate the bearing given on the board here, we are told that y from x, so it means we have to take x to locate what? Y. Usually I label those points as what? Key points. So y from x means we take x to locate y on a bearing of what? 60 degrees. So if you look at 60, it's found in the first quadrant. All right? So since it is found in the first quadrant, we are going to sketch it this way. Can we do that together? Y from x, I want to locate x first. And we are going to measure from the north, remember. So this town is x. So they said y from x on a bearing of 60 degrees. So 60 degrees is in the first quadrant. We can take it from here and then extend to any point, since we are not given the distance apart between x and y. So this town is going to be town y. But what is the bearing of y from x? The bearing is 60 degrees, so it means we have to measure from the north in a clockwise direction to the line connecting x and y. So the bearing will be 60 degrees. So if this angle is 60, what is going to be the back bearing or the reverse bearing to find the bearing of x from y? So in doing so, we are going to make sure that we measure the bearing of x from y. So this time around, we move to y and then find the bearing. Okay? So we are going to move to this point here, and then now we measure. Remember, we are moving in a clockwise direction, and the line connecting x and y is this. So since this is the line connecting x and y, how are we going to find the back bearing? So to get the back bearing, these two lines are said to be what? Parallel. So the line connecting x and y could be termed as a transversal. Now, since it's a transversal, remember the concept of what? We learn about angles in grade 9, and you are told that when two parallel lines are cut by a transversal, you can always observe what? Alternate angles. So in this case, if this angle is 60, this other angle here also must be what? 60. Why is it 60? The reason is they are alternate. Okay? So if you want again, you don't need to mention that. All you can do is remember you are given rules, and the rules are if theta is less than 180, we are to obtain the reverse or back bearing, and if theta is greater than 180, we subtract to obtain the reverse or back bearing. Now, if you look at this number 60, it's less than 180. So to obtain the back bearing of x from y, in case you don't have the idea of alternate angles, you can always see since theta plus 180 should give us the bearing of what? X from y. We can always say that since theta is 60, we can put 60 degrees plus 180. If you add 60 to 180, the answer becomes 240 degrees. The best way to prove this, let's say you cannot remember the rules of when to add and when to subtract. Like I said, these two angles are alternate. Now, since they are alternate, you can always tell that this angle 60 degrees is equals to the other angle there. Now, how will I solve to complete the results to help me get 240? Remember, if you measure from the north to the south in the previous lesson, I told you that at the north is measured 0 degrees, at east is measured 90 degrees, and at the south is measured 180. So if the movement from the north to the south is 180 degrees, which is measurement along a straight line, you are going to add 180 to 60. So if you add 180 to 60, the result will still become what? 240. So these are two different ways of solving to get the answer. Now let's move to the next slide. If the bearing of A from B is 45 degrees, find the bearing of B from A. If the bearing of A from B is 45 degrees, find the bearing of B from A. Now here we are going to draw the diagram. Remember, it's A from B, 45 degrees, and the point after from is B. We start from point B. And the bearing given is 45, is in the first quadrant, so it means we have to produce the line in the first quadrant upwards. So let's put the other location here. So this is going to be, labeled as B, and then this point will be labeled as A. So the bearing of A from B is 45 degrees. So it's going to be in the first quadrant here. So this is going to give us something like this. So remember, the bearing should be measured from the north, 45 degrees. So that's going to be this line here. So we have 45 here. So remember, among the rules given, we said if theta is less than 180, what do? We add to obtain the back or reverse bearing. And if it is greater, we subtract to get the reverse or back bearing. So 45 is less than 180. Now we are going to solve the question finally to get the answer. Remember, we are asked to find the back bearing of B from A. Now in doing so, remember, we are going to take the rules, and the rules given amongst them is if theta is less than 180, we add to obtain the back bearing. So in this case, the bearing of B from A is equals to, the bearing of B from A will be equals to, theta is 45 degrees. So we write 45, and then we are supposed to add that 180 to 180. So theta plus 180. What is theta in the question? We say theta is 45 degrees. So we add 45 plus 180 equals to 225 degrees. So this is going to be the back bearing of B from A, and then that is going to be the answer to the question. So I want students to know that to obtain the back bearing, since theta is less than 45 degrees, we add to 180, and that will give us 225. Now we move to the next slide. If the bearing of P from Q is 245 degrees, find the bearing of Q from P. I repeat, if the bearing of P from Q is 245 degrees, find the bearing of Q from P. Now, if you look at 245, is going to be in the third quadrant. If you draw the 4 cardinal points, it's going to be in the third quadrant. And the bearing is P from Q, so we locate Q first. So Q is going to be the first town. So the line is going to move from Q, from the third quadrant to point P. Now, if you locate P, the bearing is 245. So if you move right away from the north, from Q, to the line connecting P and Q, the measurement is 245 degrees. I take you back to the rules again. The rule states that if the value of the bearing given is greater than 180, you subtract. So we are going to subtract the bearing of 245 minus 180 to get the bearing of Q from P. Can we do that together? So Q from P equals to theta minus 180. Now, what is theta from the question? Right away, you can see that it is 245. Theta equals to 245. So to get the back bearing, we say 245 minus 180 will give us how many? The answer is going to be equals to, if you subtract 5 minus 0, that is going to give us 5. If we subtract 4 minus 8 cannot, with simple subtraction, we just take 1, then add to 4, and that's going to be 14 minus 8, that's going to give you 6. And then 1 minus 1, that's obviously 0. So the answer is going to be 65 degrees. If you punch it straight away from the calculator like I showed you on the screen, 245 minus 180 will give us 65 degrees. So this is going to be the bearing of Q from P. So the indication is going to be from P, you measure clockwise from the north to the line connecting P and Q. So that angle there is going to be 65 degrees. And as a 3-figure bearing, don't forget you write 0, 65 degrees. Now we move to the next slide. If the bearing of M from N is 225 degrees, find the bearing of N from M. If the bearing of M from N is 225 degrees, find the bearing of N from M. So in this case, the bearing is between M and N, but it's M from N, so we locate N first. 225 is in the third quadrant, so we are going to draw the line from the third quadrant to point M, because that is the 2 points that are connected with the bearing 225 degrees. Sorry for the diagram. If you look at the bearing, it's 225 degrees. And the 2 points there are M and N. So if you look at the number 225, it is greater than 180. So to obtain the back bearing, which is the bearing of N from M equals to theta minus 180 degrees, because that's the rule. We are told that if theta is greater than 180, we subtract. So theta equals to 225. Now, since theta equals to 225, we say 225 minus 180. What is 225 minus 180? The answer is equals to 45. So since it is a 3-figure bearing, we put 0, 45 degrees. Now this is going to be the answer to this question. So like I said earlier, to give a summary of what we have just done, the bearing of M from N was 225 degrees. The diagram was shown to you clearly. And we are told that find the bearing of N from M, which we did. So the bearing of N from M, like I said, since 225 is greater than 180, the rules say we subtract to obtain the back bearing. So we did that in the slides, and then you can see in our slide what we did. I substituted 225 in place of theta, and we say 225 minus 180, the answer is 45. And remember, since we are dealing with a 3-figure bearing, we have to indicate the 0 to make it what? 0, 45 degrees. Now this takes us to the next slide. Now in this slide, I want to challenge you students. Okay, out there, I'm expecting you to follow the rules given to answer this question. The question is, if the bearing of y from z is 315 degrees, find the bearing of z from y. I repeat, if the bearing of y from z is 315 degrees, find the bearing of z from y. So in this question, like I said, I'm not going to solve it for you. You are going to try this at your various places. Just stick to the rules that I gave you. Take your time. Observe the connection between the 2 points, y and z. and look at the bearing given, 315. Ask yourself, in which quadrant can you find this number? Is it the first quadrant? Is it the second quadrant? Is it the third quadrant or the fourth quadrant? If that is known, you can easily make the sketch to get the result. So, like I said, I'm leaving you with this question as an assignment. In our next lesson, if I come back, we can pick it up from there with the correction and then move ahead with the other parts of the lesson. On that note, before I will step out, I still want to remind you, let's keep following the advice of our health workers. Always keep safe, stay at home as much as you can. And then I will leave you for now until I come your way in our next lesson. Thank you all for listening and following.